we will welcome them. So let's talk about protobuffers today. First, we want to know what are protobuffers. It's it's a language neutral, platform neutral mechanism developed by Google for serialization data. So we use protobuffers instead of JSON, instead of XML, instead of any other way to serialize data to where it's on the network. One of its advantages is when it's serialized data, it's a much smaller a structure that is sent off the wire than JSON. So if you have any restrictions with or limitations with bandwidth or latency and that things, it will help you because it's much smaller. We're going to see examples of that and how it grows in comparison, so we can see what's going on. It uses a .proto extension files where we define the schema. This schema we will use in any project, we'll use that in any project of any language. Mostly protobuffers are used with gRPC, but that's not the only use case. We can use it in REST applications too, as I'm going to show it today. So here I have some features between Protobufs and JSON that we can see. So JSON is human read all. We have our structure with our fields. We know the field name, etc., etc. Protobuf is a binary, so we cannot read a binary. It's ones and zeros. Schema-wise, in JSON we have a loose schema type, so we don't need. It doesn't force us to adhere to that schema. In Protobufs, you have to adhere to the schema. In regards to the size of the file, in Protobuf, it's very small size of file, while in JSON, it's a medium to large size file size. We're going to be talking about all of these things later. The use cases for JSON is more commonly used on public APIs. That's where its strength lies. And Protobuf you can use on public APIs too, but it's most usually in internal or when you have latency critical applications. For example, when it's sending to mobile, you may not have that much bandwidth, so you will need a smaller size of file that you can send. And in case of JSON, it's very easy to use. We all know how to use JSON. On Protobuf, we create our proto file. Then we have to compile for each language that file to each language, and then we can use it. So there's a step in the middle. So that's a little bit more complex, but it's more, I think its strength overcomes its weaknesses. So how do we use Protobuf? We need to install the Proto compiler. There's an installation, so we can, if we go here to the Protobuf website, and in the installation, Here it says how to install for the system you're using. If you're using Linux, if you're using Windows, if you're using whatever. But the most common way I've seen people suggest using is going to the release page of Protobufs. In the assets, download whatever file you need from here, and save it to your computer, and in Linux or Mac, put it on the path directory so you can call it. That's the way most commonly used. You can use package managers too. So here they explain you can use package managers for with apt, with brew or winget. You can use those too, but the recommended version is with the GitHub release page. So how do we see if we have the Proto compiler? We can just type Proto version, and it returns this. So I have it installed here. So then since it's language agnostic, the Proto compiler doesn't know what to do by its own. We need to install language specific plugins that for it to work. In Go, we have to install this product from Google, and from TypeScript we have these two packages we need to install. So this is an example of a .protoc file. First, we need to say we're using a specific syntax, and Proto 3 is the latest syntax, and everybody where I've seen they uses this syntax, but you have to define this on the top of the file. Everybody define the package, so when you compile and decompile, it will use example.person, so it's easier to see. And then we have a message. A message, we can say, this is a type, this is your struct. In this case, is person. We have, here we define our types. So we say we have a string name, and we assign this with number 1, int age number 2. And we assign numbers to each of the fields. So that's how we're going to know what is what once we compile. So if we go here to our Proto server here, here I have a little bit of. So here I have an example that I've compiled, and when we say 1, instead of calling ID, like in JSON, you have your JSON ID colon and the number. In Protoc, we'll say ID is field 1, so it puts 1. And the 1 titles, so we reduce the number of bits using there, and we're going to be seeing that as we go. So we define our messages, that's our structures. Then we use this, for example, in Go, this is how we compile. We use the proto command, go out, paths, or all this command. And in TypeScript, it's a little bit more long, the command we type, but basically this is what we use. One thing that I learned while researching buffers is a Git feature that's very useful for this. Since we need to share this product file between projects, you can copy that from project to project, but that's prone to errors. What I found is we can use a feature called Git submodules. Does anybody know what's that? Well, the beauty of Git submodules is I created a Git repo inside another Git repo. So here I have my Git repo of my proto server. This is my Go project, and I have these schemas here. And if I go, it has a git directory with git ignore. It added this git modules file. It says you have a submodules that is its path is in the schemas directory, and the URL is this URL. So if we go to the schemas, it has a different .git folder, but they are linked together by the commit by a commit hash. So we can pull these. There's a command in Git that's the Git pull command, and I forgot. We have a recurse submodule, and that will fetch all the submodules we have. So that way we can more easily share the information, and we can not trust we have the latest version. Just Jim.
Yeah, a quick question. Do submodules, do they rely on symbolic links, or does Git manage, in essence, this nested repo?
It's managed by Git. So let me go to GitHub, and because I can show you there, and Proto server. You see here, this is in GitHub, so I cannot symbolic link this. And the schemas folder has an arrow and the commit hash. So these links, if I click here, it goes to that specific commit in that specific project. So that's a feature of Git that I learned while using Protobufs, because I was copying the schemas, and I said there should be an easier way to do this.
Yeah,
and
nice. I'm sorry, I see now. Way. Yeah, I see now that this is a way to have protodef defined as a repo once, but to use it in multiple different projects, multiple other repos.
Exactly.
Gotcha. Cool. Thank you.
So this is a gem I learned with this. Yeah, it's a little bit complex. Yes, complex to understand, because we have the idea that the Git repo is one thing only, and we have to diverge from that. And this, but it's very interesting. So let's go back. So let's see our proto definition. Here we have a definition. This line here is Go specific. We define the Go package we're going to use. So here we have a message That's a book. We have an UN32 ID, string title. You have a repeated author. So what's that? That's the way we say this is an array. We will have one or more authors. We have a publisher, and we can have enumerates. We here on the lower part, we enumerate genre with several genres, and that's a common way we have something specific, and we define the author, books, etc., etc. So let's go back to our server. In this project, what I did was I created a very simple, very basic Go project that has a protobuf route with some, so we can compare with the JSON route we have. So we can compare sizes and all that stuff. So, and I didn't create a database, but on our database, on the database, I just return an array with that I've already compiled here. And what it did is in that the directory I specified, it created this, generated this file. This is 100% generate, and it added all the code required for that schema to work. So what I'm doing is I'm using this schema file that was generated. So by this proto compiler. So you see, it's a very large file for that simple schema, and it makes all the validations and whatnot. So let's think first the authors. That's a very short array. So we curl localhost 8080 on Protobufs, both buffers and authors. We see these lines. We don't know what's what. We see three names. If we did the JSON, we have what we're most used to. So what's the difference between Protobufs and JSON here? Instead of using the ID and the name that we have repeated, they just sent for ID 1 for name 2. So it uses just 1 byte for ID and for name. So instead of in ID 4 bytes, because the quotes are 1 byte, ID, another I1, D1, quote, another 4 byte, colon, 5th byte. It uses 1 byte instead of 5. So that's how it starts to reduce the size of the file. So if we save this to an authors dot buffer, so we have the binary file. Then we can see it has a 57 byte size of this file. If we do the same with the JSON, in this very small file, we can see we have a save, we've saved space from 57 on the binary, we jumped almost to 100 on JSON. So it's almost half the size with all the benefits of that. In a larger file, so if we curl here instead of the authors, we curl to the books. That's a larger file. And the same with JSON. On the books, it's almost a third. So we can see how this works. So let's add one more book that has more fields, so we can see how much it differs. So here, that was just 2 books. We add here another book. We give it an ID of 3. Let's give with ChatGPT, with GPT. So publisher, and we added one book, one additional book. And if we go back here, and let's, we have, I'm going to leave this here so we can remember. So from what we had on the binary with 167 bytes, we jumped to 245 bytes. And from 331 bytes, we jumped to 481 bytes. So its growth is much faster than how the JSON file grows versus this binary file. So that's it. This was 3 books. Imagine you retrieve 100 books or 1,000 books. The advantages you have here, the space you will save on transmit, is important. So can we see what's in the protobuf? Yes, we can see the raw data of the protobuf. We can say we have a decode raw on the compiler, and we can save here for the authors.buffer. Sorry. It's like this. I forgot that. So we can see here what is actually sent. It sends one bracket 1, 1, 2, the string bracket versus what versus this. That's the difference between one and the other. Any questions so far?
Yeah, I have another one. Does Protobuf support comments within the schema and then also within the data itself?
Yes, it does. It's a C-like comments. So we can do this is a multi-line comment, and here we can say this is a comment.
That's one of my biggest gripes, my biggest complaints about JSON.
So you can add all the comments you like. It's very. I've been enjoying this while I'm learning. And if we go to our client, you have a client. This is a Stack router project, and here we have our schemas. That's our proto file, and here I decoded this to this generated folder, and it has all these are linting errors, so don't mind that. So they are only linting errors, but it adds all the code, so it's almost 500 lines of code in TypeScript to do this. And how we do this, you go to source. Here in queries, we just fetch the data, validate if we fetch correctly, and we respond with the array buffer, and we return that, and we decode that on the client part of the query. This is like the server. That's how Stack router works. And for the post, we pass the schema, and we use a content type Protobuffs, and we serialize the binary, and we send that. It's like JSON. You retrieve the data, serialize the JSON, and deserialize the JSON. That's exactly work-wise here. That's exactly the same. And if we go to the routes, it's exactly what we're doing here. We deserialize the data, and we can map it and whatnot. So if we go back here, this is the page. We retrieve the authors, and if we see the I don't know if you can see, but it's the response of the query is binary. And if this doesn't have any logic to save the authors, but if we new author here and hit create, it's sending everything. You cannot see the payload because it's binary. And if we go back to the server, and here we have the log that we received a new author, and here I mapped on JSON how big is the bits we have, and on buffers, on Protobuffs, how big it's everything. So we can see here too how big is one versus the other. So any questions? Because I forgot. And not everything is perfect. So everything has downsides. The first one is the human readability of the file we're transmitting. It's a binary. We cannot decode it easily to see what's actually being sent. So debugging can be a little bit tricky. Also, it's not self-describing. With the file we send, we don't know what's what. We need the protocol file to deserialize that. In JSON, you receive the JSON and you understand what fields are there and what not. You cannot retrieve one specific field from the file. You have to deserialize all the objects to retrieve a field. Its performance drops when you have very large files that are over a megabyte of size. It drops performance. With what I've researched, I haven't tried such a large file. I tried creating larger sizes, larger books, but it was very hard. With 10 books, I just reached 1 kilobyte. So you will have to send like 10,000 books on that to maybe reach the 1 megabyte size. So that's something to note. As I said, there's an operation complexity. You need that extra step of to compile that product C file, and it's yet another tool to learn with its complexity. The documentation is very good. I found it. Here you can see the documentation, how to look the limits, the style guide, how the enumerators work, how the encode is very, very, very good. How it's everything is the docs, and that's basically it. And you have all the types. So from Protobufs 3, you have here. So you have we have doubles, floats. Doubles will be 64 bits, floats will be 32 bits, int 32 and 64, and signed in. This fixed size fixed Boolean string bytes. So you can work with almost all the types we have in every language. So it's easy to, but at least the primitives you have in every language, so it's easy to work with. And one of the advantages I find is you create your migrations for your database, and you create the ones with this .proto file, and that way you share between your servers and your clients, and you define once the schema, and you don't have to define in every application its schema. I found that's an important advantage, and it's type safe. So that's it. What I have prepared. Uh, I don't know if anybody had any questions.
Did you see?
What do you mean by a compressor? I'm not sure I follow that.
Yeah, I'm guessing they mean like zip.
No, it's not. It doesn't compress nor encrypt. It's a serializer, so it transforms your data into zeros and ones, so it can send it into the through the wire. What it does, it reduces the noise. So instead of using the field name every time, it uses just a number that's much lower on byte size. That's where the difference is.
And to the second part of Hidden Stuff's question about being an encryptor, even though it's binary and it's harder to read, is it encrypted in any way? Just or
No,
let me. Okay.
it's a binary. Mm, I don't have any tools to look at the binary data, but it's just a binary.
Yeah. So if you want to,
And
you'd have to depend on one of the like an HTTPS type protocol to encrypt the transmission.
for sure, that's you still have to use a HTTPS.
Cool. Thank you.
It's most, as I said, it's mostly used on microservers with gRPC. They use HTTP2 instead of 1.1 that we usually use on the browser. Uh, I'm not sure if HTTP2 is encrypted by default.
Yeah, I don't remember.
Any other questions? Yes, Alex.
Okay, so I was wondering, I was gonna put this in the chat, but for some reason I can't find the chat button. But anyway, does it allow for like repeating fields?
Sorry, you broke here. I didn't get the last part of the question.
Does it allow for repeating fields like, I don't know, for example, like you have a person and then like maybe like two fields of different foods they like or their pets or something like that. Is there like repeating fields in that way?
Yes, so you define any structure and you added here a repeated.
Oh, okay.
So that's where you create an array. You can say, for example, I repeat the pet name. Sorry, string pet name. Pet names equals 6. One important thing that with this I failed to mention. This is forward and backwards compatible. So you can read with previous versions of the application and with newer versions. What you have to do, if, for example, I don't want to use anymore the general field, you say reserved, and you say 5, and you delete. So this reserve 5 can go on the top, and every time you need to add delete a field for any reason, you just add here the reserve, and it will send a 5 field, but it will be an empty field. So when you decrypt, you will receive, okay, we have the genre, but it doesn't have any data. So that's how you delete a field to maintain a backwards compatibility. And in older versions, they will see the pet names, but they will not know what's that. So it will skip it and do nothing, because it will, when they encode this, they will say, okay, this is it. This field 6 is a string, and they will calculate the length of the string, and they say, oh, it's this many bytes long. So it will know how to skip that. Also, the integers have the first bit of the numbers will, because sending a 64-bit number, it's a very big number, and you will not be using that often. So it sends, if it's need 8 bytes, it will send 8 bytes, but it will have a field that says if it requires another byte or not. That way, it's encoded to be the smallest size as possible. Any other questions about this or whatever at this point? If not, we're ready to close this presentation. I hope you find it useful and interesting. So thank you all for coming.
Yeah, thank you, Andres, for putting this together, and thanks everyone for sharing your time with us. We'll put this up on YouTube sometime tomorrow. We'll announce it in the Pound Announcements channel in Discord.
Perfect. Okay, everybody. Thank you.
Thanks.
And see you around.
All right. Thanks, everyone. Thanks, Andres.
Okay, bye.